Hi, everyone. Good afternoon, and welcome to our Lunch and Learn hosted by Wavelogix. I'm Suzanne Florek, and I'll be your host today. We're really glad you're here. Today's session introduces you to Felicia Bahr, our newest team member, and we're really excited to have you meet her. Welcome, Felicia.
Thank you. I'm excited to be here.
Before we jump in, a couple of quick housekeeping notes to help you get the most out of the webinar. First, we are recording this session, so don't worry if you miss anything. We'll send out the recording and any slides afterward. For best view, we recommend using speaker view, which can be toggled in the top right corner of your Zoom screen. If you've got questions during the session, just pop them in the Q&A box at the bottom of your screen, and we'll get to as many of them as we can during our Q&A at the end. And if you run into any tech issues, drop a note in the chat. Someone from our team is standing by to help. Let's start with a quick intro to Wavelogix and today's speakers. Wavelogix was founded in 2021 in partnership with INDOT and Purdue University. Our goal to help make roads, bridges more reliable and less disruptive to build. Our flagship product is the Rebel Concrete Sensor Strength System. It gives real-time in-place concrete strength data without needing maturity curves, and it works across all kinds of projects. This means better accuracy, better scheduling, and real-time saving. Now let me introduce Joe Turek, our CEO. Joe earned his electric engineering degree from the University of Notre Dame and his MBA from the Kellogg School at Northwestern. He's been in manufacturing his entire career, holds 5 patents in microwave telecommunications technology, and is a licensed professional engineer. Basically, he knows how to build things that work. And now meet Felicia Bahr. Felicia Bahr is our construction materials and testing is a construction materials and testing professional with expertise in concrete performance, field operations, and quality control on DOT and commercial projects. She's currently a technical sales specialist at Wavelogix. Previously, Felicia was a project manager at United Slab Solutions, overseeing concrete finishing operations from estimating to closeout, and led a materials testing lab at M3 Testing, focusing in at the Wisconsin DOT compliance. With hands-on experience in testing, ready-mix, contracting, and QC, she's worked with agencies like IDOT and WISDOT, managing field reporting, certifications, and compliance. Whoa, that's a lot. I'm impressed, Felicia. She holds a certificate in several certificates, including ACI Strength Technician and PCC Technicians levels 1 through 3, and is known for a practical approach to concrete performance and risk mitigation. All right, Joe and Felicia, we're going to talk about 1L cement today, and we're going to hear a lot of stories because Felicia has a lot to share.
Yeah, we're really excited to have you on board, Felicia. This is what, your third week, fourth week? How long have you been with us now?
Yeah, third week, I think.
Third week in that. Yeah, you're like a concrete superstar. That's we're really pleased to have you join the team. And you were using our product before you had joined us, right?
Yes,
Yeah.
I was. I think like I think you approached me about 2 years ago, I
Yeah,
think.
2 years ago. It took me that long to convince you to join our team. So that's we never give up here at WaveLogic. So thank you for joining us and bringing your expertise. So let's get to it. We're going to talk about 1L cement. So what's going on with 1L cement? What is it? What's changing? Give us some of your thoughts.
Yeah, well, I think everybody's heard about like what 1L is now. It's not a taboo project topic anymore. I think everybody knows about it. Right now, I mean, 1L is non-optional. It's there, it's everywhere. Type 1 and type 2 is pretty much almost impossible to find. So 1L is really the only option out there, and the mixed designs are going even further into carbon reduction because of what 1L has done in the industry. So the performance, we're not sure. Obviously, it's newer, so we don't know like how our longevity is going to be affected by 1L or anything like that. But I think everyone's very optimistic because we know we got to keep going with the carbon
Yeah.
reduction in the industry.
We got to deal with it, right? So it was kind of a shocker to our system. The changeover happened overnight. It wasn't a phase in over many years, right? And I think what we've heard from the field from many of our the contractors, they were told originally by the cement manufacturers that, oh, no problem, you just substitute 1L for your typical type 1, type 2. Your mix will stay the same. Everything will work just perfect. Don't worry about it, right? And that's that's farther from the truth. And
Yes.
it's been being used in Europe for many years, and it's a great way to reduce the carbon footprint, which is one of the reasons why it was introduced into the industry. But I think for being fair to the cement manufacturers, it's very difficult to make multiple types of cement, right? Um, they were either going to make 1L or they're going to make, regular, Portland cement. But it was hard to make both. And so I think everybody just said, well, guess what? We're going 1L. We're doing it in Europe. US, screw you. You're going to get 1L whether you like it or not. Um, just as a little background, and since you're an expert in concrete and cement, can you give us an idea what happens with what makes 1L 1L?
So the reason why it's called 1L, so all of your different cement types got one, two, three, and then now, there's a four. There's some combos, and then the 1L, the L actually stands for limestone. So they're replacing some of the cement with fine grade limestone to give you a little bit less carbon reduction. So cement is created by the clinker ground into your fine powders, and then they add the gypsum. There is obviously all the components within that makes the cement with the compounds that gives you the early strength, like a light, belite for long-term strength, and then aluminite and ferrite phases, which is the setting properties. Those compounds with the water obviously create your cement paste. Your cement paste is what's actually binding to your concrete and makes up your concrete. You can't have concrete without your cement. The clinker, which is actually the most carbon inducive part of the cement because it takes a lot of CO2 to heat the limestone to create the cement powder. With not having to go through the clinker process and actually using ground limestone versus the actual clinker, you're reducing that carbon releasing because of the high energy input and you're lowering that, which is what it gives you less clinker, which is less emissions.
So kind of a little sleight of hand. We reduce the carbon by just reducing the amount of actual cement in the mix, and you replace it with a non-siliceous material like limestone, and which is, not going to add to the binding power of the cement. And you're just like, everything's fine. Don't worry about it. Don't, but we reduced our carbon footprint.
Test it all the
So
same. What's the
yeah.
problem?
So how
Yeah,
much
not a big
limestone are
deal.
they putting into our beautiful cement nowadays?
Well, they're supposed to be at a max of 15% as of right now. I think that's what the United States kind of agreed to. Like, we're gonna stay at max. I think a lot of the DOTs also have written in their specs max 15%. But we're getting anywhere. I mean, I've seen cement manufacturers anywhere between, they're supposed to stay within the 10 to 15% with the limestone replacement. But I've seen as low as 5 all the way up to 30. They are eventually working to get to the 30%. But that is we're kind of seeing the issues come up, and I'm not sure. Honestly, I'm not sure we're gonna get to the 30 without some additional, testing and making sure it's actually okay long term.
Mhm.
But the variety of the batches can be pretty significant as far as like my ready mix contacts. I've heard people say one batch is at 10%, the next batch is at 18, which is a huge difference and it's creating issues. And I think that's the biggest part of the 1L cement, that variability of having that replacement of limestone has kind of been the hardest part of this.
Yeah, that's really interesting. So it's not regulated to say, hey, you have to have 15% or whatever the percent is, plus or minus 1%. It's a range from 0 to 15. And
Yeah.
if I hear you right, the same cement manufacturer, based on how they've batched it and that, might vary widely. and then to add to the confusion, a ready mix company, you have more experience with this, might get cement from different sources? Uh,
Yeah, they typically stay in the same source,
okay.
but it depends. There is times where they do switch, like
Mhm,
because like ready mix companies span over different, different areas. Sometimes they
mhm.
can't get that specific cement there. They go to a different manufacturer.
Okay. So they could. And as a user, as a contractor, when you order the ready mix, they're not necessarily certifying where the cement comes from. Is that correct? Or do they tell the contractor it's cement
I
from X, Y,
mean,
Z?
you can find it on your like mix designs and stuff like
Okay.
that. So when the ready mix supplier submits the mixes, they have everything on it. But
Hmm.
does contractors really pay attention to that?
Hmm.
Not really. Plus, it's not necessarily we know what batch we're going to get too. Like the contractor
Hmm.
doesn't know, hey, you're going to get a 10% batch. That is
Hmm.
solely reliant on the ready mix company to realize, like,
Okay.
hey, we need to do something. We got a batch that's higher in limestone.
Why is
Okay.
it that there's such a percentage in variation?
Honestly, I actually don't know the answers to that question. I wonder if I'm not entirely sure.
Hmm.
I want to find out. I have been kind of questioning that myself, but I think it has to do with the fact that it's just such a new process still. I don't know if they know how to dial it in exactly.
Interesting.
Yeah, probably a lot of testing from the cement manufacturers to try and optimize it. Doesn't also how finely you grind the limestone play into a difference in how it performs? Um,
I think so. I think Felicia had said that it does.
yeah.
So interesting. But so the point is, all these cement, 1L cement is different every time, or
Yeah.
a lot of
So,
times.
so therein lies a big problem, I would suspect, for our contractors who ultimately, mix batch by batch by batch may perform a little bit differently than it did last week or the month before, right? Um,
Right.
and kind of leads into where we're heading. So, where is the industry moving with Type 1L right now?
Well, it's lowering obviously our carbon footprint, which I think is
A good thing.
worldwide. What yeah, it's a great thing. It's what we're going for. Obviously, there's type 1L, there's carbon cure. Everybody, I mean, there's a ton of components that we're bringing that lower carbon footprint,
Yeah.
which is very important.
Yeah.
Obviously, we have compliance goals that, DOTs,
Mhm.
municipalities, and everyone needs those goals to meet. Plus, it helps with I think there's some certifications you can get if you have a certain carbon footprint reduction.
Cool. Yeah. It's as much as people have maybe gotten off the climate change, bandwagon and reducing carbon footprint, it still is a very important aspect in a lot of construction work today. So regardless of what side of the fence you're on, the industry is still continuing to move to find ways to reduce the amount of cement inside the concrete to reduce that ultimate carbon footprint. Would you agree with
Mhm.
that?
Yes,
Okay.
very much so.
Yeah. Okay. So what do our engineers and our contractors specifically need to know right now about, 1L cement?
Yeah, so obviously 1L is different. It's not identical as much as, they kind of teed that up saying it was identical. It's
Yep.
not. And that's
Okay.
okay. There's nothing wrong with it, right? We just need to know that what to look out for, what are we kind of seeing. The strength gain is more variable. It's a slower gaining because of having more limestone in it. It is a slower
Hmm.
gain. You're not
That's
getting that
interesting.
strength right away, which can be overcome and it could be problematic if you don't know if you're used to the type 1 2 and you're like, okay, well, I usually can get on it this mix in 3 days. Well, probably not anymore.
Mhm.
um, it's more sensitive to temperature and curing conditions due to the fact that it does have more fineness, which is a higher water demand, which
Mhm.
changes your workability. It impacts your strength because obviously your water cement ratios could be off, which causes issues for your strength. It also has some finishing issues associated to it because of the water demand that it needs. So it can cause bleeding, which is that water sitting at the top, which then can cause shrinkage, cracking. It could cause crazing. It could cause a shattered slab, which I've seen, being the fact that my last job was just doing like finished concrete. I have seen some gnarly looking slabs with type 1L. They
Mhm.
aren't as like pretty as you're used to. You're used to seeing like a hard trowel surface and you're like, oh wow, that looks really great. It's like this gray shiny surface. It can be harder with type 1L. I know the finishers for concrete firms are really getting on it and it's harder for them to finish because they're
Mhm.
trying to get that nice smooth surface like they used to, which causes density issues on the slab. The slabs aren't being as dense as they used to. Your typical slab used to be, so in order to measure your density of your slab, it's called a Mohs test. Essentially, it's taking a scratch. It's a metal scratch, with a point on it. You just scratch the
Mhm.
slab, and it'll tell you, okay, hey, it's softer than glass, it's stronger than steel. So there's like these
Mhm.
measurements. Zero being the softest, and then it goes all the way up to I think beyond 10, but we don't see anything beyond 10. In the area in the Midwest, your slabs used to be typically around like a 6 or 7 before you did anything to the slab. At just from being nice and troweled, you used to get a 6 or 7. We're looking at sometimes getting like a 3 or 4 before
Wow,
densifying it.
that's a really big
Um,
difference.
it's a huge difference. And then on top of that, so then obviously as a finishing contractor, we would add densifiers like Ashford or um Lepidolith, anything like that. Sometimes the 1L cement would cause issues with our densifiers because of the chemical reaction,
Mhm.
and it wouldn't densify the slab like it used to. So most densifiers, you put it on and you're looking at like a 2 strength gain. So for like a 4 Mohs to a 6 Mohs.
Mhm.
Now there's so much variable in that we don't know what kind of strength gain we're getting in densifying the slabs. So it's sometimes the densifiers aren't doing what they need to do. They're not penetrating the slab. They're not actually getting into the slab the way they need to, due to the fact that the fineness of the materials, there's less pores for it to get into and actually do what its job. And sometimes it repels the densifiers, which is not great because obviously the contractors spend money, the owners spend money to densify the slabs, and then they're just not being able to densify them the appropriate way. So that's obviously a huge, huge issue. To combat the high water demand, so the workability and the crazing cracks and stuff like that, we've added a ton of admixtures we would have never have seen, I don't think. I mean, maybe we would eventually, but I don't think we would have seen the amount of admixtures we're seeing nowadays.
Mhm.
We're seeing strength enhancing admixtures just to compensate for the fact that the 1L limestone is in there. So you're seeing that. You never used to see it. I mean, the admixtures is new as is, but now you got high range, you got water, you got tons of water reducers. Now you got these strength enhancers, you got these high early strength reducers, so that you can actually make up for the fact of what 1L is can kind of been causing, which then obviously increases the cost for the ready mix company, and then also gives us some more complexity
Mhm.
due to the fact that sometimes those admixtures don't necessarily play well together with the SEMs like slag, fly ash, and stuff like that. So there's a ton of different variables that the contractors kind of have to be aware of. I think a lot of the contractors have done a really good job about doing it on the fly. They see a problem, they fix it. The
Yeah.
ready mix companies, I think, are very good and they're on top of knowing what's going on. Like I said, they're adding the admixtures to get, where they need to be to meet what it used to be, which is wonderful. So seeing everybody rally together with the change is wonderful to see.
Yeah, that's good. I was at a conference that had a lot of uh, residential contractors that were pouring um, primarily, foundations and driveways. And they said, with the advent of 1L, they have ripped up so many driveways that they poured just trying to get the mix design correct. And homeowners are very particular about having a perfect driveway, right? They don't like to see cracks anywhere, even though that's natural in concrete. So it's just
Yes,
like,
yes, every
what a
concrete
what a
cracks.
nightmare. Yeah. So that's great. Well, so what we're hearing is the bad news is if you're trying to do business the same old way that you always have with regular Portland cement, you're probably going to be in trouble. But the good news is there's probably a solution that can come up with a stabilized mix. And once you figure that out, you might be in a little better shape. Um, I think we might be able to interject here that, um, you know, if you're using strength at all to make some decisions on how your concrete is curing, the methodology of using cylinder breaks in a, you know, 1, 3, 7, 14, 28 day mode, so periodic mode, doesn't really give the contractor a good feel for what's really happening in real time. And as we've been pushing a real-time data enhancement using a sensor like our Rebel sensor that gives you complete start to finish real-time strength development. Does that help minimize some of the risks then in using 1L cement? How does that help or hinder the contractor to have real-time data?
Yeah, I mean, only having more data is just going to help us. Because of the fact that variability that you get, having to add more water. Obviously, when you make cylinders, you're getting it right off the truck. Hopefully, it meets the spec. You pass slump air. Obviously, all that stuff right away, but you won't necessarily know if your strength is meeting until you break those cylinders. Obviously, your air and slump kind of gives you some correlation. Hey, yep, this mix is going to perform or it's not. Um, and obviously, the ready mix companies are doing great with that. They're sticking with that. The percentage of the air sometimes gets fluctuating with the 1L, so you can kind of see if an issue is going to arise if your air is a little bit off. Um, but obviously, that's the perfect world. Cylinders are your perfect world. They're for acceptance material only. Obviously, still very valid. We still need those. We need to make sure that all the materials being accepted. But having that real data in the field is so crucial. I mean, because we all know it's different. You're being cured under a ceiling, maybe not. Maybe it's baking in the sun. Maybe wind is whipping through it. You just never know how your actual concrete is curing. Obviously, the contractors do the best they can to get it to cure evenly and perfect. Obviously, they do wonderful with getting those slabs to cure properly, but problems do arise. And if you don't know them right away, they could be super costly. And we just want to make sure that we're seeing that data because I've always been, obviously.
Well, Felicia sure is a specialist in all of this, and she's got lots of stories to tell us. So, you know, I think the point we were trying to make here was that Rebel sensors could be advantageous to helping you solve your problem and see data early on.
The cylinder.
There you go, Felicia, you're
Oh,
back.
am I?
You were
Okay,
frozen.
I'm sorry.
That's okay.
I
Um,
don't know where I left off. What did I left off, Sue?
Well, we kind of let's pivot and let's tell some stories that you've
Okay.
seen in the field and things like
Yeah.
that. I think we could use some stories at this point.
All right. And interrupt me if I break up, I guess. Well, I have a lot of stories, so I could talk forever. But I guess the one the one story that really kind of sticks out is right when 1L came out. Luckily, I was not in the ready mix industry during that time, and so I do not envy those guys, those QC guys in the ready mix at all at this point. But I was definitely more in the testing side of things, and then I was phasing out into the finishing. The biggest thing that I had was we had a client come to us and say, "Hey, our slab just doesn't look right. It's cracking in places that we placed it the same way as we always do." We're like, "Okay, let's go out." So I went out, I kind of looked at the slab, walked all over the slab, and we were seeing craze cracking like I have never seen. Like I was like, okay, this should not happen. I know what your practices are. I know you don't use excessive water or anything like that. I'm like, what happened? And he goes, I don't know. We did the same. And it just like after like kind of diving into it, running some petrographic analysis, making sure like did the mix perform the way it needed to, and everything should have lined up fine, but it ended up being, it was right on that cusp of changing from 1,2 to 1L. It ended up being a 1L cement, and looking at it, our water cement ratio was off. It was not the way it needed to be. And it wasn't anybody's fault. It wasn't like the contractor's fault for saying, I need more water, but like you need to do what you need to do to lay it down. And that's what ended up happening. And we were getting really bad craze cracking due to the fact that that fineness, because typically before you could add water and it'd be fine, it'd evaporate out and everything would be fine. But because that fineness kind of locked it in is what's causing the crazing on the top. And it obviously was not what the owner wanted. It did not look pretty. So they ended up actually, unfortunately, having to rip it out.
Oh,
Wow.
geez. That must have been expensive.
Yeah. And
It was very expensive.
what was the ultimate solution in there? They needed more water or less water?
Well, unfortunately, the workability was having an issue. They couldn't get it to close up. It wasn't creaming the way it needed to. So they
Okay.
ended up adding more water, thinking, hey, it's gonna evaporate. It's gonna be fine. But
Mhm.
because of that fineness, it kind of locked it in and it ended up,
Yeah, from
causing
there.
some
Yeah.
delam. Yep.
For the solution from the start, if they had used more water or less water, it would have helped this problem.
If they used less water and they kind of had more admixtures in there to
Okay.
give them that workability, that would have
Mhm.
that would have helped
Okay.
them
So
100%.
little overworking, water getting locked in, and boom, Bob's your uncle. Gotcha.
Yeah.
So you have another story for us.
Yeah, so in the finishing, so when just previous actually, this happened not too long ago. I was actually at a municipal building and they were like, "Hey, the slab just doesn't look right." We're like, "Oh, okay." And we're looking at it, we're like, "This slab doesn't look like you heart troweled it at all." They did. We ended up seeing pictures. I wasn't obviously at the time consulting for them. I was at the finishing company. And so we looked at it, we're like, this slab looks dirty. Like, we're like, this doesn't make sense. So we cleaned it, we scrubbed it like 2 or 3 times, trying to get that dust off of it. And, my guys were really good about making sure it stayed clean and stuff like that. So we cleaned it, we densified it. We're looking at it, we're like, this isn't like the way it should be. A nice hard trowel surface should be nice and shiny, but it was dusty. It looked like a hand poured slab with a nice, just a normal bowl float on top of it. And so it ended up being that it had the 1L, it had carbon cure and everything in it. They couldn't get that shine the way they needed to because it was almost like dusting.
Mm-hmm.
And we were also worried about carbonization because of the CO2 allows more the type 1L allows actually more carbon to get in. So it was an
Mm-hmm.
interior slab that was sitting over winter. So they had temp heating on it. So we were worried that the CO2 from the actual temp heat was getting into the slab, which would reject the densifiers. So that's
Mm-hmm.
kind of where our concern was. Ended up not being carbonized, so that was a good thing. And our densifiers did end up densifying. We tested one slab that wasn't part of the slab that we densified, and we did gain 3%, but it still just didn't look the same. And unfortunately, the owner was not super happy about it. And we ended up kind of doing some we ended up specking that we were going to burnish it just to try to shine it up a little bit, but I think we ended up not doing it at the time. But
Mm-hmm.
it doesn't create that sleek look that everybody's used to.
Yeah. So
If
we got to get used to these new finishes on concrete and not making it architectural, but making it more structural. Yeah.
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 if you'd
Very
had
good.
some real-time data, how could that have changed both of those situations?
Well, for the first situation, obviously, I think we would have noticed the strength would have been down a little bit because of the water. Obviously, added water
Mhm.
changes our strength. So in the field, obviously the cylinders broke fine, but because they ended up having to work it and they brought all that water up, it was causing strength issues for the slab. And we wouldn't have known that ahead of time without seeing that real-time data. So that definitely, seeing that on a regular basis right away would have been super helpful. As far as on the finishing, I mean, I don't know. I did not dive into how the concrete was done or anything like that. All I'm aware of is that, it was creating a finishing problem for that job. Now, was the strength there? I'm not entirely sure. It could have been, or it could have not been.
The one of the things that we've seen with 1L, specifically when we look at and we see the data from all our customers, we see how the strength develops over time in real time. Um, that the You may end up at the strength that you want at a particular time, but how it rises or gets there varies based on the type of, amount of 1L that you have in the concrete in that mixed design. And again, having a visual to see the data as it's occurring, I think gives contractors one more tool in their box to work with as they're working their particular product. Um, we're starting to move a lot of our product to slab work. Isn't that correct, Felicia?
Yeah.
Working with a lot of the data centers that are going out, these massive slabs that they're now producing. And now it's becoming super critical because if you're putting down 1 million square feet of slab work, it's a big problem if you're not getting it finished properly and getting the strength that you need. That's a lot of concrete to have to rip up if it gets done wrong. And data centers are different from a lot of other, warehouses and things in that, you've got heavy equipment that's being placed onto the slabs. And if things are wrong and it goes bad, you've got millions and millions of dollars of equipment that are in place compared to just having a bunch of racks that you can pull out and, move and fix things. So
Yeah.
it's getting much more critical today. Um,
Well, and especially because data centers are quick moving. They're huge projects that they need to get on those slabs right away. They need to move equipment because there's so much that needs to be done within that area. So it's super
yeah.
critical.
That's great. Well, your insights have been really incredible today. It's really fun to have you on board at Wavelogix. I think that your background and knowledge will really be an add to helping some of our customers, um, mitigate their new mixes and hopefully sharing with them how real-time data will help them with some of their projects and give us more insight data-driven decisions to help them move forward into the future. And I think with that, we'll probably conclude today's webinar and open it up to any questions from the field. If there are some, Sue, we'll give some folks a minute or two to see if they have any
I
questions.
have one question, which was how environmental conditions can amplify the type 1L variability.
So, I mean, the biggest environmental would be, it's your temperature, your variation of your temperature, the wind.
Okay.
I think the evaporation rate is probably the biggest issue that I've seen with the 1L because of the higher water demand. So it can cause your craze cracking on the top and finishing issues can create because you have slower strength gain. If you're having huge temperature fluctuations like in the winter time, obviously your concrete cures slower. So you could be having even slower issues with having to not open the roadway right away because they're not curing in the best conditions.
Yeah.
Okay.
That's interesting. If I could just use a little plug for that, one of the things that we like to highlight about the Wavelogix Rebel sensor system, using the acoustic method, it's independent of temperature, and it doesn't require calibration. So if a contractor gets a mixed design with 1L that might have varied slightly in terms of the amount of limestone, as you mentioned earlier, maybe they get 8% rather than 12%, and it might have an effect on it. The sensor doesn't need to be recalibrated like the old maturity sensors where you had to calibrate it to every mix design. And then if your mix design changes, you kind of get screwed that the readings you're getting are not really accurate. Where the Wavelogix Rebel will self-calibrate or doesn't require calibration to that mix design and will pick up the variabilities from mix to mix, which I think is helpful for the contractors.
Absolutely, Joe. There was some other questions here about communication and the start of a project and trial batches, and are all those kind of things are those type of communication and different procedural evaluations being implemented into projects more? Do you find contractors doing trial batches, and is there more communication going on?
I think on the ready mix side, they've always been really good about, doing trial batches when new stuff came up. I know just recently I worked with a ready mix company that we were doing a ton of trial batches with, 1L and SEMs and, carbon cure and all the other different admixtures and stuff like that. So they're doing a really good job as far as like communicating that to a contractor. I'm not entirely sure. I think the contractor's honestly still giving the ready mix company the benefit of the doubt, saying that they're doing what they need to be doing because they truly are. Ready mix companies are nailing this type 1L thing right on the head and they're doing a good job about it. And I do know that, as far as when I worked for a ready mix company, we were always super honest with them and saying, hey, we're making some adjustments on the fly. We're doing what we can. Let me know what you're seeing in the field.
Great, great. Well, I think that's all the questions we have today. Um, is there any closing remarks either one of you would like to make?
Felicia, I'll let you go first.
Okay. Well, I'm super excited for this. I'm very excited to be joining Wavelogix and, obviously I think everybody can tell concretes kind of makes me a little nerdy and I get really excited about talking about it.
You do nerd out, Felicia. I like it. I'm learning a lot from you.
That's
So
great.
I'm really excited to bring, my field knowledge to Wavelogix, and I love the Wavelogix technology, and I did even from the start. The acoustics technology is something you don't see, and just having that real-time data is just it's phenomenal because it takes out the guesswork, and honestly, it kind of actually makes my consulting part like a little bit easier because I don't have to do a million tests because I know, hey, there's real-time data right there, and I don't have to go back and actually see what's going on with the slab.
That's great. Well, I again appreciate you all your insights, Felicia. It is fascinating how the concrete industry continues to change and evolve, and we all have to react to it as quickly as possible. But I think there's a tremendous movement to get more and more data and make data decisions, process decisions based on data, and having a reliable real-time data is really kind of exciting. And I think that having a real-time sensor like the Rebel is a great addition to any type of contractor's process that can ultimately help them make much better decisions and as an insurance policy help them from maybe having to have to rip up a lot of concrete. That isn't
Absolutely.
their fault, right? So hopefully we're helping them help all of us as we move forward. And I would say that kind of concludes today's webinar. Thanks everybody for joining us, and we look forward to seeing you in the next one.
Yep. And if you'd like to explore a pilot program or learn how Rebel could work for you, please reach out to sales@wavelogix.tech or give us a call. Check out our website. There's all kinds of contact us forms there. And we'll see you again in May. Have a great afternoon, everyone. Thank you.
Thanks everyone. Bye bye.
Thank you.